Hey guys, Isis here. Today we are going to be going over Coulomb's law. This simulation is super helpful if you're new to the concept. We have a macro scale on the home page, and we also have an option of hitting the atomic scale. The atomic scale, these two scales are the exact same except for that the measurements are different. On the atomic scale, we have our measurements in picometers, and then we have our charges in electrons. But our force will still be the same, it'll still be in newtons. For the sake of this video, I'm going to go ahead and switch over to the macro scale, just because we are a little bit more familiar with these measurements. We have a centimeter ruler down here, and we have our charges in coulombs. We have two charges right here, and then we have these two little guys who will either push or pull on these charges. So this blue one is controlled by this bar, and this red one is controlled by charge 2 bar. We have these two options right here. The force value will give us the value in newtons up here, and if you'd like it in scientific notation, that is also an option. We have the reset button down here to reset the simulation when you are done using it. So what is Coulomb's law? Word for word on Google, it says the force of attraction or repulsion acting along a straight line between two electrical charges is directly proportional to the product of the charges and inversely to the square of distance between them. So it's giving us the force value up here. So what exactly does this mean? This whole simulation is giving us the answer to our equation, which we know is Coulomb's law, which is K Q1 Q2 over R squared. We know that K is equal to 9 times 10 to the 9th. We also have a Q1 value right here. We have a Q2 value right here. And then we have the distance measured by centimeters, and that would be our R squared. If we plug all of these variables into a calculator, we would get this answer right here. So overall, the simulation is great. It shows us the relationship of the two charges of electrostatic force, and it tells us that changing the magnitude and distance will affect our Newton values directly. Hopefully you guys learned something and it wasn't too confusing, and go ahead and give it a try.